Have you ever set up a snort box? If you haven't, it's actually really fun and you should go do it. It's an awesome home lab. But that kind of dives into the intrusion detection systems and the intrusion prevention systems and the overall threat detection systems. And these are absolutely phenomenal. It's definitely needed, especially in a world where the majority of our security concerns come from misconfigurations. I've seen a bunch of Kubernetes reports that come out from a security perspective that it's like over 55% of misconfigurations, or sorry, I'm saying that backwards. Over 55% of security issues are due to misconfigurations. And I'd probably argue that like 100% of security issues are due to misconfigurations. But nonetheless, threat detection systems, intrusion prevention, intrusion detection, these are all needed. However, there's kind of a problem with them. And I don't want to necessarily say it's a bad thing. It's just how they're configured. It's how it's created. There are rules that are set and put into place to find issues. Okay. So for example, let's say like we're talking about policy enforcement and you set a rule that says your Kubernetes manifest cannot use the latest container image in production, right? That's a rule that's set as a policy. With threat detection systems, it's the same thing. There are particular rules in place that you must follow, or you get an alert or something occurs and the intrusion prevention system goes and fixes it, or the detection system sends you some type of alert. But what about issues that we don't know about? So like, for example, a crypto miner comes in and is using all of your resources. Well, you may get an alert that it's like, hey, you have high memory or high CPU, but that's about it. It's not going to tell you, hey, like there's somebody in your system doing XYZ. And the other big thing is there's a lot of false positives because again, these are blanket policies. So what may be an issue for you may not be an issue for 100 other companies using it. And that's why we kind of have like security best practices put into play, not because everybody must follow them or else. It's no, these are the standard best practices, but some may be higher up on the shelf than others. So what I want to do is I want to go through one of Kubescape's new features around eBPF and overall threat detection. And it's actually using eBPF. It's not using AI to generate anything. It's literally all eBPF behind the scenes. And it's utilizing that data to figure out things that may happen over time. So let's go ahead and dive in. Let's quickly start out by just taking a look at the new documentation here around runtime threat detection. So first things first, you got a little description up top telling you what's going on here. Showcases the architecture and how eBPF comes into play here. So it starts off with the detection system, routes to the detection engine, and then you have your alert exporter. And if we scroll down really quick, I just want to showcase the alert exporter here. You can see that you can view these alerts in multiple different places. So for example, with Prometheus, syslog, standard HTTP, and just scrolling back up here again, we can see how it works. So the runtime threat detection feature is divided into three main detection strategies: anomaly detection engine, behavioral analysis engine, and malware scanner. So let me just click on the malware scanner one here. And as you can see, it'll give you the description, the bindings, and if we go back here, it is on the same page, but I just wanted to click on it to show how that worked there. So again, we can see the detection for anomalies, behavioral, malware scanning, and then how to get started. So if you already have Kubescape running, you're just going to run the upgrade command and you're going to specify these settings via either the values.yaml file, or you can just do it right on the terminal with the set command. So in the values.yaml file, it'll be capabilities.runtime detection, and you're going to enable that. And then alertcrd.install default equals true. So those are the two values that will be changing there. And just so you know, you could see this 24-hour period that you may have to wait to see any results. All right, so let's head over to VS Code really quick. All right, first things first, I'm going to run the command that we just saw in the documentation to set these new values. And if you see an error similar to this, it looks like there is something that's already deployed that won't be available with an upgrade. So what you may need to do is redeploy Kubescape And what you're going to want to do is you're going to want to just take these settings here and add them to the default installation. So I'm going to go all the way to the end here, paste them in, copy this configuration, and do a standard install. All right, and once that's deployed, what I'm going to do is I am going to take an application that has a bunch of vulnerabilities already, just so we can go ahead and test this out. And it's called Juice Shop, and this is from OWASP. So I'm just going to go ahead and deploy it. Standard Kubernetes manifest, just specify the container image and the container port. kubectl apply -f. Go to the exact location and get this thing deployed. Oop, I actually already had it deployed here. So let's see. Yep, we can see that is running properly. So now let's head to Kubescape dashboard. Once you click on threat detection, you see a couple of different options. Now, the first thing is you see your cluster count, your node count, namespaces, pods, and containers. Those containers within the pods, of course. And right off the bat, you can see threat by severity, the trend over time, and then a couple of different detections here. But before we dive into that, I just want to show what it looks like if we filter based on resource, okay? So you can see the clusters here, right? We could filter based on that. Notice how the threat detection changes. Filter based on namespace. So if I go to default, we can see we have a couple of mediums, 5 highs, 1 critical. And I can also do this based on pod. And I think I kind of like the pod option the best because it allows you to narrow down. There's no narrowing to container option, which that obviously makes sense because the smallest unit in Kubernetes is going to be the pod. You could also narrow based on severity, but if we just do it based on pod, I'm going to snag one of these crypto miners here, maybe like this malware crypto miner. And notice here how we have 1 critical, okay? So if we go down here, we could see our 1 critical when it was found. I'm going to click on that. Okay. And notice how we have this resolve button, which we're of course not going to click on unless we actually fix it. But we can see where this is all kind of starting and where it's trailing down. So we can see the node, the pod that it's in, the container, where it's coming from. And this is, of course, the information that we need here. So all the way down to that container level. And then if we scroll down, not seeing any particular events, right? But if I click on threat info, we can see the status is open, when it was seen, the name, even the path, which is, I'm going to say this is arguably the most important piece when you're troubleshooting anything that comes up in threat detection. Because let's say I have, some critical vulnerabilities and it says there's 6 critical vulnerabilities on this node. Well, okay, that's kind of okay. And then I go and I look at the node and I'm like, oh, there are 40 pods deployed here and 50 containers. Well, okay, I have to dig through each one. No, it's not going to make any sense. But now that I know the exact path, this is the problem. This is the root cause. So at least I can go there and I can see, okay, what's happening here. And this could be for any piece of code. If you have a container running an application stack that has some type of threat detection inside of it, this is obviously a malware example, but even if it's just, Joe Schmo application running, at least you can still see where that issue is all the way down to the file and the path. Now, if we go back here, I'm going to go to threat detection again, and I'm not looking at anything specific like cluster or namespace. I'm just looking at everything kind of happening within the environment. And if I click on another one of these threats, it'll also tell you the code for the attack as well. And if I click on that, again, we can see same thing. It's going to tell me the image. I actually believe this may be, oh no, this is a different process. Okay. And then we can actually see what's happening, where it's coming from, even the command line that was utilized to kick it off, which is really awesome. And then of course we still have our path information here. And if I go to threat info, we can see what we saw before in regards to the path and the classification, which is good. The classification is going to be really helpful for those reports, for management, for leadership, maybe even for the CISO, depending on what the actual impact is of this issue. Okay, so you get a lot of information here, not only from a reporting perspective to make management and leadership happy, but you can literally see where the exact problem is and go fix it. Now, as we discussed a little bit in the beginning, this isn't happening via like AI or anything like that. This is actually all eBPF on the back end. So it's utilizing the observability and security factors of eBPF implemented on the back end of threat detection to help you with all of this. And that's threat detection in a nutshell. I personally love it because I'm not too happy with the, AI hype, so to speak. So seeing a new tool come out that's not around AI, it's actually around something really useful like eBPF, it makes me happy. Thank you so much for watching. Really appreciate it. And if you have any questions, feel free to reach out to me. Happy to help.